Okay, so right now we're just going to go over a brief recap of ratio and proportions. So a ratio is a relationship between two amounts showing how one value is part of another. So we can show it through fractions, like 80 over 100. We can show it as 80 of 100. We can show it as 80%, whether in its decimal form or just as 80%. A proportion is the act of setting two ratios equal to each other. I'm going to first read off the general rules for ratio and proportion, then we'll go over some examples so you can see how these rules play out in practice. So, rules for ratio and proportion. Number 1, make sure you are given 3 amounts and need to find a 4th amount. Number 2, make sure that you have 2 different units or the same units for 2 different things. So for example, if I have cups of flour and cups of sugar, they're both cups, but they're cups of different things. So technically, in this case, we can count them as different units. 3, when comparing our ratios, our units in the numerator and denominator must match exactly. So what that means is that, for example, the cups of flour and cups of sugar, we would have to have both cups of flour in the denominator or both cups of flour in the numerator. We don't want to switch these around. We don't want to have cups of flour in one denominator and then cups of flour in the numerator of the second one. Both ratios have to have cups of flour in their denominators or in their numerators. 4, fill in X for whatever unit you're trying to find. 5, cross multiply, so numerator times denominator, then set equal to each other in order to solve for X. So to summarize this, I usually just like to say, take your given, so the ratio that you're fully given, so you're given the numerator and denominator for it, and set it equal to what you're trying to find, which is the ratio that has your X value. And then you cross multiply to solve for X. So now let's look at some examples of this. Okay, so the first example that's already given says if 3 bottles contain 225 tablets, then how many, which we know is our X value, would 4 bottles have? So right now I can see that 3 bottles have 225, so that's a relationship. And it's asking how many would 4 bottles have. We can connect these. That's a relationship. So we know that our given is going to be 3 bottles equals 225 tablets. Whenever we make a ratio out of something equaling something else, like 3 bottles equals 225 tabs, we can either put the bottles in the numerator or denominator. It doesn't matter. In this case, we put the bottles in the numerator, tablets in the denominator. Whatever you do, you just want to make sure that you follow the same format for what you're trying to find. So right here, we put tablets in the denominator. And because of that, we had to put tablets in the denominator over here. For a given, we put bottles in the numerator, and then we had to do it here as well. So you just want to make sure that you match up your units. So erase that so we can see better again. Our given was that 3 bottles over 225 tablets. We're setting it equal to what we want to find. So it says, how many would 4 bottles have? So 4 bottles, that's a given amount. We put that there. Tablets is what we're looking for. So cross multiply. So when I say cross multiply, I mean multiply like that. So you're going to take the 225 tablets and multiply by what's across from it. So that would be the 4 bottles. You're going to take the 3 bottles and multiply it by the X tabs. And once you do that, you get 3X equals 900. And in order to isolate X, divide both sides by 3. And then you get 300 tablets. Moving on to problem 1. It says, ratio and proportion requires 3 numbers, 2 different units, and an X or an unknown value. So technically, you're going to have 4 values. 1, 2, 3, 4. But you're actually going to have 3 numbers filled in. 1 will be an X. Moving on to number 2. If there are 8 grams per milliliter of medication, so we know that this is going to be a ratio, and it's going to be our given ratio since both amounts are given. How many milligrams would be in, erase that so we can see, 5 milliliters. So right now, let's just kind of write this all out. We have 8 grams over 1 ml. Anytime that the denominator is not given like this, you can assume it's 1. So per milliliter, per 1 milliliter. We're going to set that equal to what we're trying to find. So we're given 5 milliliters. And we're going to have to solve in grams first, since in the numerator in our given we have gram. We want to eventually find milligram. So what we're going to do is find in gram and then convert to milligram after solving. So 8 times 5, because we're cross multiplying, is 40. X times 1 is just X. So this would be 40 grams. So to convert it to milligrams, this is a metric conversion. So I'm going to write out my acronym. Keene Henry died by drinking chocolate milk. So right now we're going from our base unit of grams to milli. 1, 2, 3. So we moved 3 units to the right. So now we're going to do that with our decimal point in 40 grams. 40. 1, 2, 3. So now it would be 40,000 milligrams. Okay, now let's move on to problem 3. Let's say you're making a cake and you need 2 cups of flour for every cup of sugar. If we use 3 cups of sugar, how much flour will we need? So that's automatically going to be our X. This is going to be our given ratio. So anytime that you see 4 of whatsoever in between 2 amounts, you know they go together. So right now we see our keyword of 4 here. So we know that these 2 amounts can be connected. Also, these can be connected. So I'm going to write 2 cups flour in whatever kind of format I gave my given. I need to follow that with my what we're trying to find. So here I put cups of sugar on the bottom. So I need to make sure to put cups of sugar on the bottom for my trying to find amount as well. So 3 cups of sugar. And then my X value is the flour. Okay, cross multiply. We get X equals 6 cups of flour. Okay, so for number 4, it says, if 12 bandages come in 1 pack, how many packs will the nurse need to grab to get 72 bandages? So this is going to be your X value. These amounts go together. These amounts go together. Remember, in between that means they're 1. I'm just going to set this up over here because I don't have any room. 12 bandages per 1 pack equals I'm just going to write B to abbreviate that for X packs. Okay, cross multiplying, we get 12X equals 72. Now we need to divide both sides by 12 in order to isolate X. And we get 6 packs. Okay, now number 5. If 30 patients can be scheduled in a day, so 30 in a day, how many days, this is your X value, would it take to see 100 patients? So these amounts go together, these amounts go together. So I'm just going to put 30 patients over 1 day equal to 100 patients. Patients are both on the numerator, days are both in the denominator. Okay. Now that we have that set up, now we need to cross multiply and solve for x. 30x equals 100. Divide both sides by 30 to isolate x. And we get 3.33 days. Okay, so now for this problem, we got a tub of grout, but the tub only gives directions on if you want to make the whole tub of grout. But let's just say you only wanted to make part of it. So ratio proportion can help you with this. So for the whole tub of grout, it says that you get this much powder that you then have to mix up to create the grout paste. So this is the powder, and this is how much water they want you to mix. And from finding those two amounts, you should be able to solve using ratio proportion. So let's kind of go over the example here. What is our given here? So if you're trying to, find out how much water you need to add to a smaller amount of powder, you would first find out how much water it requested you to add to the normal amount of powder. So right here, I'm going to write my amount of powder over my amount of liquid, or grams over milliliters. Here, we're given kilograms. We want to find it in grams. So I'm going to do a metric conversion first. King Henry died by drinking chocolate milk. Here we're going from kilo to our base unit. So 1, 2, 3 to the right. I'm going to move my decimal point 3 to the right. 1, 2, 3. So now we have 450 grams. This amount here, we don't need to change it. It is 104 milliliters. So there's our given. So for every that many grams, you need to add that many milliliters in order to make the grout. Next, number 2 says, let's say we add 123.5 grams of powdered grout to the scale and decide that that looks like it's all we'll need. How would we set up our equation using ratio proportion? Basically to figure out how much water you need to add to make the grout. So let's take our given, 450 grams, 104 milliliters, set that equal to this amount, 123.5 grams equals X amount of milliliters. We're trying to find out how much water we need to add to this amount in order to make the same consistency of paste that you would get from doing this. Next, number 3 just asks you to solve the proportion that you have already set up in number 2. So let's cross multiply and solve for X. So 450x equals 12844. Divide both sides by 450 to isolate x, and you get 28.5 milliliters. So that's how much water you need to add if you are only going to pick up 123.5 grams. So less than this. In the previous examples, we reviewed problems that included the given within the problem. These givens were included because they were specific to the situation. Now, let's review some examples where the given is a known non-specific ratio that can be memorized or looked up upon when needed. So one example of a given that, you might have to look up, it's not going to necessarily be, spelled out in a problem, would be something like how many pounds equals how many kilograms. So right here we can see that for every 2.2 pounds, we have 1 kilogram. I know it says equal here, but sometimes when you're looking up things like this, you write that actually as a ratio, and that would be your given. So let's just say I weigh 130 pounds and I need to know how many kilograms that is. You can solve using ratio proportion. I'll show you guys right now. So 2.2 lb over 1 kg. Basically, just turn this little equal sign into a ratio. You could put 1 kilogram over 2.2 pounds, or you could put 2.2 pounds over 1 kilogram. It doesn't matter as long as you align your units once you add in your trying to find amount. So now, I told you guys, let's just say I'm 130 pounds. How many kilograms would that be? So this is how you would set it up. Then you would cross multiply and solve for x. This conversion factor is constant. It doesn't change. That's why, you might have to look it up in a given conversion factor. Other things like, if you're putting people into groups and you want to see the ratio of that, or, whatsoever, scheduling patients in a day, that all might be included in your problem. Another one that you might have to look up, it's not going to be in a chart, but you might have to look it up on a vial if you're working in a hospital, would be milliequivalents. So in the real world, sometimes you'll need to find the givens yourself, and milliequivalents is a great example of that. So milliequivalents are how we measure electrolytes, which are different elements that your body needs, things like potassium or sodium or whatsoever. So on your vials, this is, act like that's a drug vial. So this is going to be potassium chloride. Potassium chloride, we'll say that it is 40 MEq per 20 milliliter. So if you're trying to find out how many MEq is in part of this vial, let's just say this whole vial is this 20 milliliters. If you want to know how much is in part of it, you can do that using ratio proportion. So an example of this would be 40 MEq over 20 ml are given. And let's just say we have 5 milliliters and we need to know how many MEQs is in that specific amount. I'm putting milliliters on the denominator because that's where it is in my given. And then I'm going to put X MEQ in the numerator because that's where it is in my given. Cross multiply and solve for X, and there's your answer. And all different electrolyte vials will have different MEQ ratios, so you have to look on the vial for that one. For instance, magnesium sulfate has the ratio of 4.06 MEQ for every 1 milliliter. Another example of when you would need to look up your own given is if you're trying to find out exactly how much active ingredient of a drug is in a certain amount of, liquid, or if a certain measurement of, cream or, whatsoever. Let's just say you're taking a tablet. Let's just say you have an amount of cream. Let's just say you have, a solution or suspension of drug. That whole amount that you're taking isn't going to be your active ingredient. A lot of that is just filler. A lot of that's just mixed in to help you take a powder or whatsoever. So sometimes you need to figure out, what your actual dose is of the drug. So the example that I'm going to show you guys is of daptomycin, which is an antibiotic solution. It's taken IV. So you would be giving it, into someone's veins. And Dapto is 500 milligrams of medicine per 10 milliliters of solution. So in order to give this concentrated powder into a vein, we have to mix it with a little bit of saline. So this is active drug. And this is Saline is salt water. Sometimes it's mixed with different powders in order to make them solutions so they can be given in your veins. You can only have solutions given in your veins. You can't have powder chunks whatsoever. So in order to kind of provide the right route to deliver the drug, we mix it with certain things like fillers or solvents. In this case, this is what we would have per vial of Daptomade. But let's just say that, we only need to give the patient a 6 milliliter dose, and we want to know how much drug that patient is getting in that dose. We could solve this with ratio proportion. 500 milligrams over 10 milliliters, which is your standard. Set it equal to what the patient got, which is 6 milliliters, and find their dose. Cross multiply, solve for x, and there you go.